design an FIR filter, first with Fourier series method, then with window technique method, and at the end we have discussed how it can be designed with frequency sampling method. Okay, so that is the different types of windows, different types of filters, how it can be designed with different methods. So that already we have discussed. So today we will start with the second type of digital filter, that is IIR filter. Let us write down the title of that. Just write the title as just note down the syllabus of sixth unit. Just note down this 6th unit syllabus. Is my screen is visible?
Yes, sir.
Yes, sir.
You please write down the syllabus of Unit 6. Hope you are all writing. It is IIR filter design by impulse invariance, IIR filter design by bilinear transformation, in bracket problems of filter design up to third order only, in characteristics of Butterworth filter, IIR filter implementation technique. Or have you finished writing of syllabus?
Yes, sir.
So what are the textbooks used here? Can anyone tell me? The previous textbooks what we have used, that all same textbooks we can use for this also. So you just write the textbook used is digital signal processing. This first one you just write digital signal processing principles, algorithm and application. Digital signal processing principles, algorithm and application by John G. Prokis. Can be used as a textbook again. Throughout this complete syllabus, you can use only 2 books. That is sufficient. One is John G. Prokis and other one is Ramesh Babu. For examples again, if you want. The reference book is again, you just write reference book, digital signal processing, reference book, digital signal processing by Ramesh Babu. That is 4th edition scientific publication. So these are the textbook and reference books we are using to understand this particular chapter. Or
Yes, sir.
now let's move further part. As I have at the start of the unit 5, I have given the difference between FIR and IIR filter. Yes or no?
Yes, sir.
What is the difference? What is the full form of IIR filter? Can anyone tell me? Full form of IIR filter.
Infinite impulse response filter.
It is infinite impulse response filter. Okay. So what does it mean? So what is the difference in FIR and IR? What is the difference in FIR and IR? Can anyone tell me please, so that I can move ahead? As already we have discussed. What is the difference? कोई बताएंगे?
FIR filter has finite duration unit sample response and IIR filter has infinite duration unit sample response.
Okay. What else again? What is the next difference? What is the next difference?
Feedback is absent in FIR.
Hmm? Yes, please.
Nature of FIR filter. Nature of FIR filter is non-recursive and nature of
Okay.
IIR filter is recursive.
Then what else again?
FIR is more stable and IIR is less stable.
Okay. Then
Feedback is absent in FIR and present in IIR.
very good. What else again?
Sensitivity is less in FIR and comparatively more
Okay.
in IIR.
So hope you all know like what is the main difference in IR and FIR. So as we have discussed already about FIR filter in 5th unit, like how FIR filter can be designed with the different methods. So likewise here in this particular chapter we are discussing how IR filter is designed with the different methods. There are, according to your syllabus, only two methods are there. Like one is impulse invariance method and another one is bilinear transformation method. Okay. So you please note down this title. Today's title as like IR filter designed by impulse invariance method. They may ask you like this derivation also as a theory question. Write down the title. IR filter design by impulse invariance method. You can write if you want. ठीक है? Have you noted?
Yes, sir.
So here the main purpose of moving this is, as we all know that IR filter is a digital filter we are calling. The purpose क्या है यहाँ पे कि we need to convert analog transfer function to the digital transfer function with this impulse invariance method. What are all the specifications we are getting? Those are in analog transfer function nature. So those functions we need to convert into the digital. So that is what the main purpose of studying this derivation. Okay. So let us write down. Parallelly, I will just explain you. Just note, let the impulse response of the analog filter, let the impulse response of the analog filter be that is be HA of t, be HA of t. Here H of t is the impulse function. A stands for the analog filter. Then the unit sample response of the corresponding digital filter, the unit sample response of the corresponding digital filter is obtained by uniformly sampling the impulse response of the analog filter. by uniformly sampling the impulse response of the analog filter. So can anyone tell me, as we have studied already the sampling theorem, what for we are using that? कैसा लिख रहे हैं हम? What is sampling theorem? Can anyone tell me? What is sampling theorem? Anybody? Hello? What is sampling theorem?
Fs is greater than or equal to 2f.
That is okay. Statement of sampling theorem is Fs is greater than or equals to 2f max. Okay. Then what for we are using that? How we are converting? The another purpose of going for the sampling theorem is to convert continuous time signal to analog signal. बराबर? Yes or no?
Yes.
How we are writing that? हम लिख रहे हैं कि यहाँ पे पता है कि x of t is equals to, we are writing it as x of, that is like here converting analog signal. How we are writing that is x of nt. लिख रहे हैं ऐसा, right? And this we are calling it as x of n, where this t is the sampling period. Getting my point? Yes or no? So this is the way we are just converting analog signal to the discrete signal with the sampling function it is. So here the t is the sampling interval we are calling. That t, as we already done the condition like ts is equals to 1 by fs, where fs is greater than or equals to 2f max. ये अपना condition है. ठीक है? So now likewise here what you have written? क्या लिखे थे? Anyone?
The impulse response of analog filter.
Sampling the impulse response of the analog filter, full stop. You just write. We know that the sampled signal is obtained by, we know that the sampled signal is obtained by putting t equals to nt, t equals to nt. Therefore I can write h of n is equals to what we can write it is ha of nt, right? We can write it as h of n equals to ha of nt, where n is equals to 0, 1, 2. Let's call it as equation 1, where n equals to 0, 1, 2. Let's call it as equation 1. After that, you just write one line. Here, h of n is the unit sample response. Here, h of n is the unit sample response of digital filter, and capital T is the sampling interval, full stop. Just write next para. So this is, in the first part we have understood how this h of t is converted into the digital form, that is h of n. So where h of t is the impulse response for the analog filter and h of n is the impulse response for the digital filter. So this is the first part. Okay. Then in second part, just write, let the system function of the analog filter, be denoted as system function. क्या है यहाँ पे? How we are representing? What is system function? Or what is the other name for system function? What is the other name for system function? Yes, anybody? What is the other name for system function? Have you heard the word system function? और पहले बार सुन रहे हैं? Have you heard the word system function?
No, sir.
No. Very good. Have you heard the word transfer function?
Yes, sir.
The transfer function itself, we are calling it as a system function. That is the other name for transfer function. Okay, just write down. Let the system function of the analog filter be denoted as HA of S, be denoted as HA of S, full stop. Let us assume that the poles of the analog filter are distinct. Let us assume that the poles of the analog filter are distinct. Then its partial fraction expansion analog filter are distinct, full stop. Then its partial fraction expansion can be written as just write HA of S is equals to summation k equals to 1 to n Ck divided by S minus Pk. That is P with suffix K. Right. Let us call it as equation 2. Okay. So this is how the transfer function or the system function for the analog system we are writing. Just write where Pk is poles of the analog filter, where Pk poles of the analog filter and Ck coefficients of partial fraction expansion, and Ck coefficients of partial fraction expansion. Okay. Next. Have you written this part? Yes or no?
Yes, sir.
Yes, sir.
Next line you write. The impulse response of the analog filter. H of t can be obtained by taking inverse Laplace transform of the system function, H of S given in equation 2. H of S given in equation 2. Now, if I want to take the inverse Laplace transform of this, that is, we are writing the inverse Laplace transform of this, then I'm going to write it as this h of s can be written as HA of t, which is equals to, the summation will remain same, k equals to 1 to n, then as this ck is the coefficient part, which will remain same again into. So can anyone tell me what I can write this? It's going to be like e power pkt. So this is what the function where t is greater than or equals to 0. Let us call it as equation 3. Summation k equals to 1 to n ck e to the power pkt, where t is greater than or equals to 0. So this is equation 3. Okay. So this is what we are calling like analog filter, that is h of t, which is obtained by inverse Laplace transform to equation 2. Understood?
Yes, sir.
Yes, sir.
Now, let's move to the next part. We just write the unit sample response of the digital filter. The unit sample response of the digital filter is obtained by the unit sample response of the digital filter is obtained by. क्या कर सकते हैं अभी इसको? Can anyone tell me how I can write the digital filter now? Yes, unit sample response of the digital filter. How I can write that? तो बता सकते हैं मुझे क्या चेंज करने से आपको डिजिटल फिल्टर का इंपल्स रिस्पांस मिलेगा अभी?
Replace T by N.
Replace t by the value what? लिखे है हमने, like in the above equation we have written replacing t by the value nt. बराबर? फर्स्ट पैराग्राफ में लिखे है हमने how we have converted analog to digital is by replacing t by nt. तो ये वही प्रोसीजर यहाँ पे अप्लाई करेंगे हम अभी. Write down the unit sample response of the digital filter is obtained by uniformly sampling HA of t. HA of t, just write this h with suffix a of t, that is we can write it as h of n is equals to HA of t at what value of t? T should be replaced by nt. HA of t which equals to tnt, or simply we are writing it as, this is equals to, we are writing it as HA of nt, or what I can write finally here is summation k equals to 1 to n, the ck term will remain as it is, then e power p k, this t I am replacing it by the word n t. Let us call it as equation 4. The t is replaced by the term nt. Call it as equation 4. Understood?
Yes, sir.
Yes, sir.
Okay, so this is the way how we have converted analog impulse response to the digital impulse response. Then you just write next line. Next line. Now the system function of the IIR filter. The system function of the IIR filter can be obtained by the system function of the IIR filter can be obtained by taking Z transform of H of n. Can be obtained by taking Z transform of H of n. What is the formula here? Formula of Z transform is? What is the formula we are having for Z transform? H of Z is equals to, the formula is summation n equals to 0 to infinity, summation n equals to 0 to infinity, H of n into Z power minus n. We just substitute the value of H of n here from the above equation. So this is a definition of Z transform. So if you substitute the value of H of n here, so n equals to 0 to infinity. H of n is what? We have written it is this way, like summation k equals to 1 to n ck e power pk nt multiplied with the value z inverse. Sorry, z to the power minus n. Or simply this can be finalized as, what we can write? This can be written as h of z equals to, we can write it as h of z equals to this can be written as h of z equals to summation k equals to 1 to n, summation k equals to 1 to n. This ck is the independent of constant term, so I can take it outside. Then summation k equals to n equals to 0 to infinity e power pk, it is t is there, pkt z inverse whole to the power n again. Let us call it as equation 5 whole to the power n. Then how I can express this part? Anyone? Can anyone tell me? कैसा एक्सप्रेस कर सकते हैं उसको? It is the term in the bracket is like again summation n equals to 0 to infinity a to the power n. तो फॉर्म में कैसा लिख सकते हैं हम उसको? So this term is like the term which is going to be n equals to 0 to infinity a to the power n. Okay, इसमें उसको कैसा लिखेंगे? Yes. What is the formula for that? We know that if we have a value summation n equals to 0 to infinity a to the power n, then what I can write for this? Formula क्या है इसका? हेलो, am I audible?
1 minus a raised to n divided by 1 minus n.
1 minus a raised to n divided by, that is different thing मैडम. It is simply अगर आप इसको एक्सपैंड करते जाएंगे, चलो और थोड़ा आसान बताता हूं मैं आपको. a to the power 0 plus a to the power 1 plus a to the power 2 plus a to the power 3 plus dash 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 ऐसा आता है. ठीक है, तो ये it is like 1 plus ये आ जाएगा. So simply we are writing it as 1 divided by 1 minus ये. So this is the formula already we have seen. ठीक है. So based on this, how we can write for equation 6? Equation 6 कैसा लिख सकते हैं हम? कोई बताएंगे मुझे अभी? How I can write the equation 6? Yes, h of z is equals to क्या चेंज होता है अभी वहां पे? This part will remain as it is. Summation k equals to 1 to n will remain as it is. Then this ck will remain as it is into. So what I can write? What is the value of a here? So 1 divided by 1 minus a. A is what? What is the value of a? Hello?
E raised to pkt z inverse.
E raised to pkt into z inverse. Right? Or else finally I can write it as summation k equals to 1 to n ck divided by 1 minus e raised to pkt into z inverse. Right? Let us call it as equation 6. Let us call it as equation 6. Now, if you compare equation 2 and 6, what is the difference you are observing? Can anyone tell me? If you compare equation 2 and 6, क्या difference है? Yes? Up to this equation 6, any difficulty, any question? Hello?
Sir, ते 1 by 1 minus a कसं आलं? A raised to n sir.
N equals to 0 to infinity. This is the standard formula, madam. 1 divided by 1 minus a. So a to the power 0 is 1 plus a to the power 1 plus a to the power 2. So this is what the formula we have seen already. 1 divided by 1 minus a. Standard formula is there. Still you are having confusion?
हाँ sir.
No, this is the formula. Already we have used many times this formula. ये formula ये है अपना 1 divided by 1 minus ये आता है यहाँ पे. So this is what the formula we have used. ये formula कुछ अलग है क्या आपके दिमाग में इसके related?
नहीं sir.
Like suppose if we have here like let us see, like we have energy equation हमने calculate किए थे, ठीक है? Summation n equals to 0 to infinity. Suppose if you are like a equals to 4 to the power n, तो इसको solve करना है तो कैसे solve करेंगे आप? अभी a का value 4 है यहाँ पे. So how you are going to solve it? So it is like 4 to the power 0 plus 4 plus 4 square plus 4 cube up to dash 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 infinity. ठीक है? So this we are writing it as 1 divided by 1 minus 4 as the value. So this is what, like, what is the value here? 1 divided by 1 minus 4, or simply we are going to write it as minus 1 by 3 is the value. So this is the way how we are solving it. Yes?
Okay, sir.
और अभी यहाँ पे और एक कंडीशन था वहां पे, राइट? इफ वी आर हैविंग द वैल्यू ऑफ a should be, if the value of a is less than 1, then we are writing this formula. ठीक है? एक्चुअली ये गलत है मेरा. If the value of a is greater than 1, how we are writing the formula? If the value of a is greater than 1, then we are writing it as 1 divided by a minus 1. So it should be like 4 minus 1. So will be as a plus 1 by 3 will get. Yes or no?
Yes, sir.
Is that clear now?
Yes, sir.
Okay. Now, if you compare equation 2 and 6, what is the difference you are observing? Equation 2 क्या है आपका? Denominator term is what?
S minus PK.
S minus PK. Wherever you are finding S, it is called as an analog system. The analog system are represented with the notification S, and the digital systems are represented with the notation Z. Can you remember these two words?
Yes.
Yes. Yes. जैसे कि आपका आपका लैपलेस ट्रांसफॉर्म है. लैपलेस ट्रांसफॉर्म कैसा लिख रहे हैं आप? एच ऑफ एस बोल के लिख रहे हैं, राइट? वेदर इट इज कंटिन्यूअस और डिस्क्रीट. Laplace transform is like h of s we are writing. So that is again a continuous transfer function, right? So here, wherever like h of s function is there, that is an analog system function. And wherever the z term is there, that is a digital system function. Now, thus we have obtained, you just write, thus we have obtained the transfer function of analog system function, the transfer function of analog system function of equation 2 to digital system function, of equation 2 to digital system function of equation 6, of equation 6. That is what we can write. We can write it as equation 6. Shall I wrap this complete part? इसको रब कर सकता हूं मैं?
Yes, sir.
Of equation 6. So therefore, what we are writing is here. First thing is, पहला हम analog form लिख रहे हैं. It is like analog is what? 1 divided by S minus PK is the analog term. Okay. So this, if I want to converting it into the digital form, what I am writing is 1 divided by 1 minus e power PK T into Z inverse. So this is what the relation we are finding while converting analog to digital form it is. Understood? Any question here or any problem? Any question or any doubt? Hello? Hello?
No, sir, no doubt.
बोलो ना यार, कोई तो भी थोड़ा बोलेंगे तो मैं आगे जा सकता हूं. Next, you just write. So this is how we are converting the analog transfer function to the digital transfer function. You just write next line, like some generalized forms we will write here based on this, such that we can use directly in the example those generalized formulas. Just write above result can be above result can be extended. Above result can be to extended to multiple and complex conjugate poles, multiple and complex conjugate poles, full stop. The S to Z transformation, S to Z transformation, S to Z transformation relationships are as follows. S to Z transformation relationships are as follows. So we can write, if we have first term as like 1 divided by S plus pk to the power m, it is like multiple poles we are calling, then its transfer function is written as minus 1 to the power m minus 1 divided by m minus 1 factorial into d to the power m minus 1 divided by d to the power, that is dpk to the power m minus 1 into 1 divided by 1 minus e power minus pk t into z inverse. Let us call it as, this is, let us call it as equation 7. This we are calling it as equation 8. Then further we have one more form, that is s plus a divided by s plus a square plus b square. Then its transformation we are writing it as 1 minus a to the power, it's not a, e to the power minus at cos bt into z inverse, cos bt into z inverse divided by 1 minus 2 e power minus at cos bt into z inverse plus e power minus 2at into z power minus 2. And one more form we have, it is, so we can write, if it is b divided by s plus a square plus b square, then its transformation is written as e power minus at sin bt into z inverse divided by 1 minus 2 e power minus at into cos bt z inverse plus e power minus 2at into z power minus 2. Right? So let us call, this is equation 9 and this is equation 10. So these are the some standard functions we are going to use while solving the examples again for the conversion of analog system to the digital system. Or have you finished this? अगर कहीं पे कुछ समझ में नहीं आ रहा है तो प्लीज आस्क. Simply don't write the way how you are going to understand. Or
Yes, sir.
Yes, sir.
okay, so this is all about how we are designing an IIR filter using impulse invariance method. That is how we are converting like analog transfer function to the digital transfer function. So for today, we will stop it here, and further we will take up the examples related to this. So let me close the session here. If anybody is having any doubts, you can ask me. Still 1 or 2 minute time is there. Otherwise, you can leave.